So on page 178 of your student journals, we're going to be talking about exponential functions today. And this week we'll spend the first couple days on that, and then we'll move on to doing some other graphing. And then next week at some point we'll have our chapter test. We'll be about done with the chapter, which means we'll be done using this textbook series, and we'll be going back to our older book. So just kind of keep that in mind. You're going to wrap this up here in the next. So exponential functions, let's go ahead and work on this one right here, and then actually move on to the second one and do this one. Don't worry about the ones on your right here. Just do the first column. So these two. Work with a partner on them, please. Get into some cool exponential function stuff today. All right, here we go. So this beginning one here says work with a partner, complete each table for the exponential function y equals 16 times the quantity 2 to the power of x. Now, the problem I've seen in the past with students doing these is that sometimes they kind of go in the wrong order here. Okay, so we've got the x power. We need to put these values in for x. So if we have this, we're evaluating this as 16 times 2 to the 0. 16 times 2 to the 0, well, 2 to the 0 is what? 1. 1 times 16 is 16. Okay, now those of you who did 16 times 2 first and got 32 and then raised to the 0, and got 32 as your answer, it's not quite right. Yeah?
You have to write the equation out in the boxes.
No, you just put the answer, that's fine. I'm just kind of showing what you need to do there. So we've put in the value 0 there. Here we're putting in the value of 1. So 16 times 2 to the first. Well, 2 to the first is 2 times 16 is 32. Okay? 16 times 2 to the second. 2 to the second is 4. 4 times 16 is 64. What's our next answer? 128. And then? 256 and 512. What's happening every time here? Yeah, very good. It's multiplying by 2. Okay? So we get a constant. What's happening here for x? Yeah, we're adding 1. So as x is increasing by a constant amount each time, y is increasing by a constant as well. However, the constant we're increasing by on x is addition. This is multiplication. It's a bit different than linear, where as this went up by a constant, this added or subtract, or this increased by a constant by adding or subtracting. Well, now as we're going up by 1, this is multiplying on that. It's going to change what our graph looks like. All right. So on this guy here, 16 times 1/2 to the 0. Well, that's again 16. 16 times 1/2 to the first. 1/2 to the first is 1/2 times 16 is 8. 16 times 1/2 to the second. Half to the second is 1/4. 1/4 of 16 is 4. What's the next one? 2 and what do we get next? 1. And next? 1/2. Okay? So what's happening every time? Yeah, you're dividing by 2. Dividing by 2 is the same thing as multiplying by what? Yeah, it's multiplying by 1/2. So we're dividing by 2 there, or we could say we're multiplying by 1/2. We generally talk about how we're adding or how we're multiplying here. So in this case, we're multiplying by 1/2. And once again, this is increasing by 1. Okay, so as we have our x value increasing by 1, that multiplies by 1/2. So do you think the statement below is true for any exponential function? As the independent variable x changes by a constant, the dependent is multiplied by a constant. Now, did we see that on both of these? Yeah. How many of you remember doing exponential functions last year? Doing exponential growth and decay? That's kind of what we're getting into here. All right. We're going to start graphing these here. So if you turn it, go ahead and turn your page. And I gave you a different piece of grid paper to help out here. But this on page 179. The top says work with a partner to sketch the graphs for exploration 1 and 2. I want you to sketch them on this piece of paper though. All right? So we're going to take our equation, y equals 16 times 2 to the power of x. Okay? And we're going to graph that one. Then in the next one, we're going to graph y equals 16 times 1/2 to the power of x. Now you'll notice a couple things on these grids that I gave you. I've got a place for you to fill in your table right here where you can show your rule. Now your rule is, anyone remember what the rule is here? What goes right here? Did it a bit earlier this year.
The equation.
Yeah, part of the equation, this portion, the expression piece. We're going to put in the 16 times 2 to the power of x. Just gives us a place to show our work. Then you'll notice right here, this says y-intercept. Okay, so I want the y-intercept in the middle. Now it's tough to figure out what the y-intercept if you haven't graphed it already. But think about when my graph, no matter what my graph looks like, when it crosses this axis, what is x? Yeah, 0. So our y-intercept is going to be when x is 0. So as long as we know that, we can calculate the y-intercept. Okay, so if I put 0 in, what did that give me out? Yeah, 16. Okay. And then we want to go points on both sides. So we could pick like 1 and 2 and -1, -2. You don't have to use those, but those seem to be the closest. That allows us to now fill in our table. Please keep in mind, if my y-intercept is 16, does that mean I'm going up by 1s here? Probably not. Okay. So once you figure out what you want your scale to be, how far you're going to have to go up, that's when you're going to define that. So if you have to go to 100, maybe you write this as 100 up here. You have to go up to 20, maybe you write it 20 here. Okay, and that way you can calculate, you can figure out what each line is going to represent. All right, go ahead and work with that. Work on those two with your groupies there. Get everyone's attention back up here. I'm seeing quite the variety of graphs out there. So first thing, as you're going through and putting these in, we actually came up with values for the 1 and 2 already. That gave us, oops, sorry, that was 2. So 16 times 3 got 32. And here we had 16, and that was 4, or excuse me, that was 2. So 2 squared is 4, and 16 times 4, that's 64. Now, how many of you got those points right? Most of you had those, okay? Now, some of you, though, as you progress, you put the negatives in. Pay close attention here. This is where some of you, I saw some mistakes there. 2 to the negative first. Remember, 2 to the negative first is actually, 2 to the negative first is 1 over 2 to the first. You guys remember that from exponents? Okay, so that's just half of 16. This is 8. Okay, so some of you right here had negative 32. Okay, and 16 times 2 to the negative second. Well, 2 to the negative second, once again, 2 to the negative second is 1 over 2 squared, which is 1/4. And 1/4 of 16 is 4. The other way you can think about it, look at your pattern. You had cut in half, cut in half, cut in half, or double, double, double. So that's got to kind of continue there. So as I'm going here, I have to get up to 64. Did anyone go up by 5s? Does 5 work? Anyone give me their scale?
I went up by 7.
What'd you go up by? 8? You went up by 7? Okay. I'm gonna go 8s just because 64 goes into it. 7 would work too. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. So there's 10 of them. So I'm gonna just define that by putting 80 at the top. That tells me that I have now went up by equal increments of 8. by writing 80 up there. Okay? So now if I say, well, at -2 I'm at 4. That is half of 8. This represents 8. There's 4. At -1 I'm actually at 8. At 0 I'm at 16. So there's 8, there's 16. At 1 I'm at 32. That's 4 8s. And then at 2 I'm at 64. All right. Very good. Then we connect them. Or go through them. Draw our arrow. Nice job. How many got a graph that looks like that? Okay. How many figured out the little mistake they made? I saw a lot of little mistakes, but like if you don't catch the little mistake, it makes it look like you made a huge error and nothing matches up. Like if you put negatives up there, your graph looks kind of like a U or a V. Okay. If you didn't draw the appropriate scale, you might have like a linear graph, a straight line, because you just kind of plotted things without making equal increments on the y-axis. All right. Let's try the next one here. We're going to make y 0, or excuse me, x is 0. 16 times 1/2 to the 0 power. That gives me 16. Same y-intercept. We've already figured out when x was 1. When x was 1, what was y on this one? What was it? 8. Okay. When x was 2, what was y? 4. Okay. So we put -1 in. 16 times 1/2 to the -1st. Okay, so remember, once again, that's 16 times 1/2. And -1st power. 1/2 to the -1st is going to make that become 1 on the bottom and 2 on the top. So that becomes 32. And you can follow that pattern, right? You got 4, 8, 16, 32. What's this one going to be? 64 if you're going up by the same amount on the x side. For those of you doing this on your calculator and you're like, well, my calculator's giving me something different, just make sure you're plugging it in correctly. Batteries are low. Okay, so if I go 16, I've got the 1/2 to, say, the -2nd. Make sure you, if you're not using a TI-83, that you put the whole thing in parentheses. What did I do there? Oops. There we go. So we get our 64. Okay. Put your phone away. All right. The other thing you could do is put it in your y equals menu. 16 and 1/2 to the x power. Like that. And then you could use your table feature. You've got your numbers there as well. Okay. Use the y equals menu. It's a nice route to go. If I hit graph, some of you did that on your graphing calculator earlier on. You saw the graph. Okay. So if we're graphing it, what do we want to go up by?
8.
Yeah, let's go up by 8 again. Yeah, pretty much the same graph.
Yeah.
Gonna look the same?
It will. It's like flipped.
It's like flipped? Yeah. You're gonna have the same 0, 0 and 16, but 1 this time is at 8. 2 is at 4. Yeah, it's kind of flipped around. It's actually a reflection. Got it. 2. This is reflecting over the y-axis there. This is called growth because as you're going across the x, y is going up. This is called decay. Growth and decay. Okay, so as x increases, y is increasing. Here, as x is increasing, y is decreasing. So as x is going up, y is going down. And here on growth, as x is going up, y is going up. Questions? All right, tell your neighbor what the y-intercept was for this graph. Let's circle it. It's right there. Why don't you label it? What's that number? What's the y-intercept on both the graphs? All right, Jake, what do you got?
What do you mean?
Like, what's the y-intercept? 16. Good. Has it changed here? No? 16 there as well. Where could we have found that number 16 in our equation? Dude, that right there. That number is always our y-intercept. Okay? This number is always our y-intercept. Whatever number is out in front of this thing, we actually look at this in the form of y equals ab to the power of x. A is always your y-intercept. All right? So you've got to start thinking like in our equation earlier in the year we did y equals mx plus b. What was our y-intercept there? Yeah? B. So when we're dealing with these equations, our y-intercept is always a here. Okay? So if I'm taking a look at, say, like number 5, we're not going to sketch these graphs right now. Is there a number out in front of the thing being raised to a power? All right, I want you guys to identify, if we're using the form y equals abx right now, I want you to identify a. Circle a in all of those equations. Using the form y equals abx, circle a in all 6 of those equations. Most of you have a pretty good idea where a is. A is the thing that is not being raised to a power. So if I look at these numbers, the thing that is not being that does not have a power attached is a. So you guys, we got to get in the habit of looking at a general form and going, okay, a represents a number. So like in this problem right here, there's 2 numbers. There's a 2 and a 3. Which one is a? Okay? 2. It's the thing not being raised to a power. In E, there's a 3 and a 1/2. Which one's a? 3. It's not being raised to a power. That means my graph, if I had a graph right here, I'm not going to sketch the graph, but if this is my x and y axis, my y-intercept would be 3. It'd be right there. Okay, if this is going up by 1s every time. Okay? Letter F. My y-intercept is? Jaden, what do you think? Yeah. Letter F. 2. Okay. Cole, what do you think here? 3. Okay, these were the 2 I saw most of us mess up on. How many numbers do you have?
1.
You only have 1 number this time. Is it being raised to a power?
Yeah.
So 2 is not my y-intercept. Okay, so a lot of us circled 2 here. What are you multiplying 2 by? Yeah, by 1. Okay, so if you don't see a number there, then your y-intercept is actually 1. If you don't see a number here, your y-intercept is 1. Okay? The a is your y-intercept. This is your rate of growth or decay. Okay. All right. We got it? That's our exponential function. That's kind of what we're dealing with today. Okay, we're not going to graph any more of those. Any questions? Okay, so what I want you to do, let's go ahead and take a look at page 180. Almost done here. Page 180. On page 180 it says graphing got our core concepts here. You can define exponential function. Maybe you want to summarize what y equals abx means there. And then over here, they've kind of went through what happens if b is bigger than 1. How your graph goes up like this. But if it's less than 1, okay, or excuse me, if a is greater than 0, if a is less than 0, your graph starts going downward. So like if a is a negative, it reflects across the y-axis or the x-axis. Okay. And this is your decay. And once again, if x or if a becomes negative, it just reflects across the y. We've seen if b changes to a number in between 0 and 1, it reflects across the y-axis. If a is negative, it reflects across the x-axis. All right. Your assignment is page 181. All right. You can, on numbers 8 and 9 on page 181, you can draw tables right below it. Okay. I would suggest making a table that looks something like this, just so you have what you need, and putting your y-intercept in the middle. I do that for each of those. All right. There you go.